So let's take a look at a demonstration now. So again, what we can do is we can look at our IEBGENER, and we can look at creating this new data set, as well as copying this data set, which is what we've done in the previous units. But this time we want to take a look at putting it all together so that we can see exactly what it looks like. We also are going to look at printing the data set. So in other words, we are going to substitute the output file with an output queue entry to demonstrate the flexibility that JCL provides in what the output destination can be for data. In looking at the JCL now that we have here, again, we see the job card, we see the execute card, but now let's look at the DD statements and what these all represent. The sysprint statement in this case here has a sysout equal asterisk. And remember, the asterisk indicates we are going to use the same output class as we have coded in our message class parameter on the job statement. So in this case, since message class is equal to V, that's going to be where our sysprint output goes as well. The sysut1 indicates our input data set in an IEBGENER. And as a result, we have our data set name indicating the data set that we want to copy. In this case, gatom2.old.dataset, and we've coded a disposition equals share, which allows anyone else to continue to read this data set while we are using it. Our sysut2 indicates the data set that we want to copy it into. Now, since this data set does not exist, we are coding all the parameters in order to create it. So in this case, we've given it a data set name of new.dataset. Our disposition parameter is a new catalog, but since new is the default, we haven't coded it here. Instead, we have a comma indicating the absence of it. So we are taking the default of new, and then we are indicating we want to catalog this data set when we are done processing. We continue that on to the next line, which shows a unit equals sysda, indicating that this is a disk data set. Our space parameter indicates that we want our allocation in tracks. One track's primary, one track secondary. We can continue on to the next line after that, where we have our DCB parameter indicating a logical record length of 80, a record format of fixed block, and by coding a block size equals 0, we're telling the system to calculate the optimum block size for us. Then our final DD statement is our sysInDDDummy. This is where control statements would normally be entered. Since we have none, we're indicating that this is a dummy data set, so when IEBGENER attempts to process it, it'll be treated as an empty file, and nothing will be done there.